lecture podcast series. I'm your instructor, Brian Krause, and today we're going to be discussing the three major rock classes, igneous, sedimentary, and metamorphic, and we're going to talk about their basic attributes. As always, in this mini lecture, like all the mini lectures, I'm not going to cover all topics or ideas presented in the text. Rather, my aim is to highlight a few of the key ideas and discuss them in a bit more detail. On that note, let's get started. At the end of this lecture podcast, you should be able to describe the origin and characteristics of igneous, sedimentary, and metamorphic rocks. Rocks are the most common and abundant material on the Earth. When a rock is examined closely, we find that it consists of smaller crystals or grains called minerals. And minerals are chemical compounds, or sometimes they can be single elements, such as gold, each with its own composition and physical properties. So the nature and appearance of a rock is strongly influenced by the minerals that compose it. In addition, a rock's texture, the shape, size, and arrangement of its constituent minerals also has a significant effect on its appearance. And we'll be discussing that shortly. So a rock's mineral composition and texture, in turn, are a reflection of the geological processes that create it. So rocks can be divided into three major groups: igneous, sedimentary, and metamorphic. Igneous rocks are found in areas of high volcanism, so in areas with lots of molten rock. Molten rock beneath the surface is called magma, and the molten rock at the surface is called lava. When the molten rock begins to cool off, it is going to crystallize, and you'll get mineral crystals. Eventually, you will get enough mineral crystals, and it will solidify into solid rock. Igneous rocks are classified based on mineral composition and texture. One of the most important variables of magma composition is the relative amount of silica present. So magma with a relatively large amount of silica generally cools to form felsic igneous rock. And then magma that relatively low amount of silica generally cools to form mafic igneous rock. The texture of an igneous rock is determined primarily by where and how the molten material cools. So slow cooling of magma beneath the surface leads to coarse grain texture, while rapid cooling of lava on the surface leads to fine grain texture. Igneous rocks are generally subdivided into two main categories based on where the rocks formed: intrusive igneous rocks and extrusive igneous rocks. Let's first look at intrusive rocks. So intrusive rocks form within the Earth. You tend to get very, very slow cooling over thousands of years. The slower the cooling of magma, the larger the crystals form. The texture of these minerals are either coarse or very coarse. So very coarse minerals are larger than 10 millimeters in diameter, while coarse minerals tend to be between 1 and 10 millimeters in diameter. So here are a couple of pictures. The first is granite, which is a coarse grain texture and a felsic igneous rock. The other rock here is a gabbro, which is a coarse-grained mafic igneous rock. The next type of igneous rock is extrusive rock, and these are rocks that are formed at the surface of the Earth. They are extremely fast cooling and gives you small crystals. Sometimes the cooling is so instant that you don't get any crystal formation at all. So there are three textures that we will identify. So the first texture is fine, which is smaller than 1 millimeter in diameter. The second is glassy, where there's no crystals at all. And the third is vesicular, which means you have gas pockets trapped within the rock. So these rocks, you do need a magnifying glass to see the crystals since they are so small. So two examples of these are rhyolite and basalt, are two good examples of fine-grained extrusive rock. Now let's turn our attention to sedimentary rock. Sedimentary rock are derived from pre-existing rock by the process of weathering. Some of the processes physically break the rock into smaller pieces with no change in composition, while other processes decompose that rock. That is, there's a chemical change in the minerals into a new mineral and a new substance that is readily dissolved in water. So there are three types of sedimentary rock we're going to talk about. There's clastic, chemical, and organic. Clastic rocks are the most common rocks found on the surface of the Earth. The way clastic rocks are formed, larger rocks need to be broken up. That is what is called weathering. So those broken up rock fragments need to be moved, and this is called erosion. So the most common erosional agent on the Earth is water. Now those broken up rock fragments are called sediments. After those sediments have been carried for a long distance, they are going to be dropped off, which is then called deposition. And once those sediments are deposited, they will be buried. Now the more layers of sediment that you get, the greater the pressure applied to the underlying sediment. Now this pressure, which is called compression, is going to cause compaction of that sediment, which means those sediments get closer and closer together. And once they get nice and close and packed together, they are going to get glued together by something called a process called cementation. The second type of sedimentary rock, chemical sedimentary rocks, are formed from two processes. So the first process is what is called precipitation. So basically what happens here is too much of an ion tries to dissolve itself into water. So what happens when water dissolves a substance, and this is what we call a solution, there's only so much room in that water to dissolve that natural substance. So once the water becomes completely filled up with that substance that's trying to become dissolved, we say that solution is saturated. If there's too much of an ion trying to dissolve itself, eventually it will fall to the bottom of a lake, a stream, or an ocean, for example. Eventually, all those ions will crystallize into rock, and that is what is called a precipitation. And those rocks that are formed are called precipitates. The second type of process is what is called evaporation. And water is a very good dissolver of substances. So what tends to happen is water has dissolved substances in it, and water will evaporate off, and the substance that was dissolved in the water does not turn into a gas and remains. So that is what evaporation is, and the substance dissolved in the water is left behind. So the product that's left behind is called an evaporite. So the last type of sedimentary rock we have is organic rock. These rocks are made from dead plants and animals. So the two rocks you should know are coal, which is made of dead plant, and limestone, which is made of cemented seashells. So metamorphic rocks are produced from pre-existing igneous and sedimentary rock. These rocks are formed solely by heat and pressure. So where does this heat and pressure come from? Convergent plate boundaries. These rocks tend to be made without melting. If these rocks got heated enough to melt, they would turn into igneous rock. So there is a fine line between metamorphic and igneous rock in relationship to the heat. So metamorphic rocks are going to be found in true mountain ranges. This figure here represents a continent-to-continent convergent plate boundary, which represent India crashing up into Asia, creating the Himalayan mountains. So the Himalayan mountains are true metamorphic rock. There are two different types of metamorphism that a metamorphic rock undergoes. The first type is regional metamorphism that are going to occur at convergent plate boundaries, specifically where you have continent-to-continent convergence. So regional metamorphism means that metamorphism of a rock occurred over a massive area, like found in a mountain range, for example. So again, think of the Himalayan mountains as a classic example of regional metamorphism. With regional metamorphism, you now get into what is called foliated rock. Because of its intense heat and pressure, these rocks are going to have mineral alignment or mineral banding. And these minerals are going to align themselves into rows in the sense that you can see specific patterns in the rock. So here's a great example of this foliated rock due to regional metamorphism, where you can see this mineral banding, or these minerals aligning themselves by these different colors. You can see the white stripes going through this rock. So this is a great example of a foliated rock due to regional metamorphism. The second type of metamorphism is called contact metamorphism. And this is going to occur in areas where there is lots of volcanism. So this is where the magma and lava are going to touch or come into contact with the rock. Because of the intense heat of the magma or lava, that intense heat is going to bake that rock it is touching, and it's going to alter it into a new rock. And that's the important part. It's going to become a new rock. So these rocks are not nearly as dense as regional rock because they don't undergo or they don't have that intense pressure to create them. So contact metamorphism rock is going to take place where the magma below the surface or the lava at the surface touches the rock. At that contact point, the rock is going to be altered and it's going to change. So on that note, this concludes this lecture podcast. Talk to you soon and have a great day.